Cool. All right. Hi, I'm Drew. I'm going to be talking about privacy bridges and Ethereum compatibility. I'm the founder of a protocol called Webb. Here's my email if anyone wants to reach out to me after the talk, or follow me on Twitter at zknark. And so this talks about privacy and bridges, and obviously Ethereum. So why not start with the state of bridges on Ethereum? There's a lot of bridges being built. Some of them are live, some of them less so. But overall, there's a tremendous amount of bridges. And currently, there's no privacy layer for any of them. There's bridges that are being built out in Cosmos, Polkadot, between Bitcoin with wrapped tokens, Near, and so on. But something that's really interesting to me is whether we can add privacy to these bridges. And the answer is yes, we can with zero-knowledge proofs. And we can do so in quite a novel way. We can benefit from something like shared privacy, in the same sense that some chains talk about shared security. We can come up with a notion of shared privacy where anyone who uses any bridge, as long as it's sort of the same consistent private bridge, will benefit from a shared privacy. So how do we use, or at least what is zero-knowledge used for in privacy? Well, zero-knowledge proofs allow us to make privacy-preserving escrow mechanisms, something like Tornado Cash. The amount of privacy we get depends on the total number of funds in the pool. And the more funds we have in the pool, the more privacy we get. So when we talk about increasing privacy in this world, we talk about increasing the anonymity sets for these pools. Next, we can discuss how we can use zero-knowledge for interoperability. So zero-knowledge allows us to prove complex statements about potentially large data sets, like what are the Merkle roots, or at least, what are the leaves in a bunch of Merkle roots, prove membership about these sets. And so at least for interoperability, we are interested in proving statements of the following sort, like a one of many Merkle membership proof, or one of many Merkle membership proofs over a set of like client header hashes. And the benefit we get when we make these types of proofs is we get an interoperable anonymity set. And what that means is basically I can have funds locked in one side of the bridge, and it can contribute to privacy anywhere else that this pool is connected to. And so that's something that we're building out at Webb across the entire space. So what is Webb? Webb is meant to be the privacy layer for bridges, and the goal is to deploy Webb everywhere. So definitely on Ethereum, definitely on any smart contract chain that can support our zero-knowledge primitives. And the goal over time is to decentralize this protocol and make it as trustless as possible. So we've been building in the Ethereum ecosystem and in the Polkadot ecosystem, and we'll continue to expand. And so what does this bridge look like, or at least the first version of this bridge? We're really interested in bringing Bitcoin and stablecoins to, or at least building anonymity sets for these types of tokens. So the first version of the protocol looks very simple. You wrap Bitcoin into a new representation, and you lock this into an interoperable mixer. And then you can transfer this wrapped Bitcoin across the ecosystem to wherever the deployments are, and withdraw it potentially if the liquidity permits. So at least in this example, there's no end liquidity on the right side, or at least on the Polkadot side. So there's nothing you can unwrap it into. But we can think of, so how does it work? Basically, each side maintains a mixer or Merkle tree. You're going to deposit things into it. We're depositing these web-wrapped assets. We have a set of incentivized relayers who move the Merkle roots of these Merkle trees around. The users will generate withdrawal proofs with that more complex zero-knowledge proof statement. And finally, they will withdraw. So that's like the first basic flow, and we'll use that flow, for all instantiations of this bridge. But the more interesting incarnations of this bridge are when we add complexity to it. So obviously there's a lot of different types of assets that exist in all different types of ecosystems, and we're interested in growing the amount of privacy that exists for all of these assets at the same time. So one of the most, at least for me, interesting instantiations of the protocol is for doing something similar to a stable swap, where we're going to wrap multiple types of Bitcoins all around the ecosystem into a consistent representation. And there were some talks yesterday by James, who was talking about optics, and the main discussion around bridges is the representation of assets that exist. And this is sort of the main thing when you talk about bridging assets, in my opinion, because assets across a bridge are new. They're not really the same types of assets. But with a protocol like this, we can continue to add new representations to each side to wrap into our newly private wrapped assets, and then contribute or at least grow privacy for everyone that uses it everywhere. So in this example, you can take a variety of Bitcoin tokens on Ethereum, wrap them into a Webb BTC set token, and potentially unwrap it for inter-BTC on Polkadot. And finally, in our roadmap, the third and final thing that we're working on is to sort of add risky and yield delegation primitives to this bridge as well. So people will be locking liquidity into these bridges, and we can do things with the underlying liquidity. We can lend them out while people are at the same time moving their private assets. So in some sense, the private assets always provide an IOU to the underlying liquidity, and we can add different risk levels to that IOU. In this case, there is risk putting these assets in these protocols, and the users who use the risky set bridge might accept that risk because they might earn yield in doing so. And the interesting thing is when you build this across chains, you can start to take advantage of potentially differing interest rates, and it provides for interesting, potentially bad behavior, but nonetheless a really useful piece of infrastructure for privacy. And so while building this out, you obviously want to connect to Ethereum. So Ethereum becomes sort of the main constraint when building a private bridge, or at least an interoperable privacy project. Why is that so? Basically, Ethereum only supports one pairing curve. And so this is a fairly weak pairing curve compared to what currently exists in the research literature, in the cryptography space, and something we need, at least I think, this ecosystem needs to embrace is faster deployment of new curves. So the BN254 curve, a lot of people are critics of it, and ultimately it's not a super secure curve compared to what else exists, like BLS 381. When building out a private bridge, it becomes extremely, extremely important to make all the primitives that you're using on this bridge consistent. So along with the curve, it becomes really important to make sure you have consistent implementations of your hash functions and your elliptic curves in different languages so that you can build at least these primitives everywhere in Golang and Rust for different ecosystems and so on. And we basically use these curves not only to do zero knowledge, but eventually, as many other projects are doing, to aggregate signatures for relayers to make the system work a lot more efficiently. So yeah, we are targeting at least to deploy this with both curves, at least because our system is general in that way. But we do want to support BLS 381 in the long term. So at least getting that on Ethereum is quite important. I was recently chatting with some people at the conference who mentioned that this precompile, or at least the inclusion of this precompile, won't be prioritized for ETH2, which seems kind of odd considering, I mean, from my perspective, adding features like this only improves the types of applications that developers can build, and so I would support it. And so yeah, with BLS support, there's already a tremendous amount of implementations of this curve out there. There are precompiles that are sort of standardized and compatible with one another, and so the tech is ready now to integrate. And so yeah, as I said, when we talk about Ethereum compatibility, we are talking about compatible implementations in many languages, as well as compatible implementations in our zero-knowledge circuits, and for pretty much all the EVMs in this ecosystem to also adopt those precompiles. And so using BLS as the bedrock, we just really need compatible hash functions. We're using Poseidon right now. We use it in the EVM, and we also use it in WebAssembly. We need some consensus process for agreeing upon parameters, because these hash functions require parameters. And finally, we need to run trusted setups for these bridges. And yeah, so I mean, this is really cool to me. It's really interesting because private bridges allow us to scale anonymity sets in many different dimensions. We can scale them across similar assets so that all the stable coins on Ethereum contribute to the same anonymity sets, as well as all the stable coins that eventually exist everywhere. They can all wrap into a consistent representation, and we can even govern this representation to add new stable assets into and remove from this set. So it becomes quite a flexible system for growing privacy of a specific asset class. And then the next benefit is ultimately these private bridges become platforms for developers. So once you have a private bridge where you can move assets between chains privately, you can also start to build different types of DeFi applications on top of it. As I showed in the third version or the second version of the protocol, you can build stable swapping mechanisms, yield aggregators, and eventually you can start to generalize this system to support not only assets, but different types of data. So right now, most privacy projects on Ethereum and in the ecosystem have focused primarily on asset privacy. In the first case, we have something like Tornado Cash, which does pretty atomic asset privacy. Here, we're trying to build at least interoperable asset privacy. And third, once we accomplish this goal, once we build out our protocol, we're going to generalize this so that we can do interoperable data privacy. So you can prove statements about data that exists in different chains on whatever chain you might be interested in. And yeah, we've ultimately been focused on the EVM and with Rust in Substrate, actively hiring. So if you know of anyone or are interested, please reach out or send me an email. This is our website, web with 2bs.tools, and that's our GitHub. Definitely check it out. We got we're building out some cool stuff. But thank you. That's the end. I'll take questions if anyone has questions.
Which one did you use? I'm curious about, since you want to have the largest possible anonymity set, you want to introduce these stable swaps. I mean, that kind of puts you in the same position as Curve. You're taking on weird counterparty risks because WBTC is custodial, SBTC is synthetic. They can fail in different ways, and if one of them fails, you end up in your stable swap with one just now you have 99% of the really bad asset, that kind of thing. I'm just wondering what you're thinking about that, because it seems like it's sort of a problem you need to tackle, but it's also orthogonal to the already complex problem you're solving. So, yeah, what's your thought on that?
No, good question. So it's worth noting that every instantiation of the bridge is really a separate bridge. And then to go to answer your point of like who's going to take on the risk or why would they accept the counterparty risk, something we're thinking about is if people join, say, a very simple bridge like this, they wrap their WBTC in, and this is all it provides. It's, in my opinion, like a low-risk system because there's always only one asset to take out. We can give the governance power to these holders, these Webb BTC holders, to vote in whether they would want to accept something like SBTC into the set. So that's one way we can handle this type of risk situation is by giving the voting power to the people already in the pools. They vote to accept the risk. Secondly, we can just create a separate bridge entirely and let users sort of choose whether they want to in the first place at all. So we can just create an instantiation of a bridge like this where at the onset 3 types of Bitcoin tokens are able to be wrapped into this new wrapped asset. We haven't yet looked at the, whether we want to include a type of curve-like functionality when you're wrapping and unwrapping, just because it does complicate, certainly when you go across chains. We're trying to, I'm playing with where you might take a fee within the system, perhaps when you wrap, to prevent at least too much, behavior that wants to arbitrage in and out of these tokens. But yeah, good question.
Anyone else? Oh, yeah. One, two.
I was wondering if you could speak a little bit about the relayer infrastructure that you have that supports the bridge. I know you mentioned, and I missed the first part, but yeah, maybe if you could go into a bit more detail about how that works and who's running the relayers and how much they can introspect into the transactions.
Another good question. Yeah, right now the relayer section, so the relayers, they agree on the Merkle roots of all the deployments or all of where the bridge deployments are. They're basically oracles over the Merkle roots. And right now we're using a modified version of Chainbridge to at least update these Merkle roots. This is like the first most primitive way that we're handling it. But the goal is to aggregate, do off-chain signature aggregation to update the roots and try to do some batching techniques to improve the efficiency. Right now, with how Chainbridge works, you're stuck with a fixed relayer set. But the goal is to do some proof of stake election somewhere. Ideally, it's going to live on one chain and use that to, yeah. We want to do proof of stake election to run a DKG. And people who at least are, what's the word? Registering to participate as a relayer, they would have to provide like key shares to participate in this DKG. And if people aren't familiar with DKGs, they're distributed key generation protocols. So we want to generate effectively a shared public and private key under a threshold system and use this to update the roots. So we'll run like a pretty, hopefully large MPC in the end. Did that answer your question? Yeah, so part of at least how we're thinking about it is that wherever the fees are generated, they will go to, a portion of them will go to these relayers.
Thank you.